Okay. Hi, everyone. Good morning. Thanks for your time. So I am Fani Penmetsa. I'm the head of Solutions Engineering and Architecture at CloudFabrix, and I also lead the technology delivery to our partners and customers for both pre-sales and post-sales. Okay, quick disclaimer. So these sessions are intended to give a quick insights about our product, CloudFabrix, RDAF platform. Cover all the core concepts and provide lab guides and exercises, which allows you to get sense of what the product is all about and its core functionalities. How the product works, how you can use it. But in whatsoever. It's not a replacement of our documentation. Obviously, for the detailed information, please refer our documentation guides, and also please reach out to us. If you have any questions that may not have covered in these sessions. So these sessions are spread across 4 days, and on the day one today, we are going to focus on quick intro to our core platform, which is RDAF platform, and we are going to go through its architecture and how it can be deployed. What are the quick best practices and its supportability and scale, and some of the core platform artifacts, and followed by user access management. And at the end, so we have prepared lab exercises. So we have shared the details about the lab environment, and we have created 8 seats, 8 participants sharing with another user. 16 participants can practice the labs. Okay, so the first module we are going to talk about a quick intro about our platform. We'll go through overview of RDAF platform. Okay, so our main platform is RDAF core platform. It is also known as Robotic Data Automation Fabric, which is our foundational and core platform, which was built on top of cloud-native architecture, which means like it can be deployed either on-premise, either in Kubernetes cluster, or plain vanilla Docker containerized environments. It can be deployed in on-premise and public cloud like AWS, Azure, GCP, or it can be offered as a fully managed SaaS offering as well. And the platform is being very data centric and built with a low-code, no-code framework, which allows seamless integration with different data sources. And on top of this platform, we built core solution offerings, and some of them are AIOps is one of our core solution offering, and asset intelligence, and leveraging our low-code and no-code platform, and composable dashboards, very rich analytics engine, and it allows you to build your own custom service as well. Okay, quick overview about what is this all about RDAF. So it is designed to manage data in heterogeneous, domain agnostic, multi-vendor, multi-cloud and multi-site environments at scale. And it allows you to integrate any IT operations data sources in both directions, and allows you to cleanse and transform the data to address the siloed and unstructured data challenges that you typically see in IT operations in environment. Some of the core capabilities of RDAF is, of course, not limited to. Some of these are, it has an ability to ingest and transform, aggregate the data, and process the vast and continuously, real-time data being generated in IT operations environments, and and across the data being generated, various IT infrastructure components, application and monitoring tools, right? And with its core, data automation platform, it provides inline, data cleansing, allows you to transform the data, enrich the data, and add more context to the incoming, real-time alerts and events. And it allows you to discover your assets, infrastructure, virtual, bare metal, physical, containerized environments. It allows you to build the application dependency, mapping. And, as the data is being ingested into the platform, with the data cleansing and data transformations, it allows you to apply the clean data and feeding that information to, machine learning and to apply certain use cases like trend analysis, baselining, anomaly detection, and forecasting, and and also it allows you to visualize the data using our rich analytics, reporting framework. And as it integrates with many data sources, finding the data, searching the data is one of the core components to make it easier for operations team to look for the data that they are looking for. So as it integrates, right, so different data sources will have different query language. For example, if you're interfacing with your log management solutions like either Splunk or Elasticsearch or OpenSearch for that matter, each of these databases or data lakes will have their own search and filtering query languages. So what we do is the platform provides a unified SQL-like friendly query language using which you can query any data from any source in a consistent and efficient manner. And it provides an ability to receive the event notification or alert notification, process them. Even it can send the notification to outbound from the platform from one to many sources. As a platform, it is very, very extensible, and it allows any data integration with these with its data-centric approach. And it supports all the industry standard programmatic interfaces like SSH, SNMP, APIs, message bus integration with streaming live data, both inbound and outbound. So as we talked about what the core capability of RDAF platform, this slide gives you a quick picture how a typical enterprise IT operations environment can be, how complex it can be. It can have many tools, right from your infrastructure element managers, your IT operations monitoring tools like ITOM tool, and then your data lakes and your log management tools, and you have SIM tools, and you have ITSM tools with the change management and ITSM ticketing and whatnot. And at the same time, you have a very heterogeneous multi-vendor, hybrid environment running the workloads on-premise and running the workloads in cloud. And you have a traditional applications versus cloud-native containerized applications which runs on Kubernetes clusters and virtualized environments and bare metal environments and whatnot. So when you have such complex environment and the RDAF platform being very flexible in integrating with all of the sources, it allows you to ingest any type of data source from IT operations environment, let it be metrics or events, logs, traces, asset inventory, right? So as the platform is very data-centric and domain-agnostic platform, which simplifies and accelerates the journey to the AIOps adoption. When it comes to AIOps, it is a adoption and journey in the sense of how your current IT operations and environment is being operated manually to automated to self-sufficient with AI and ML techniques. So with that in effectiveness and integrating with all of these data sources, It allows you to address the challenges of data automation as it needs to integrate with a wide variety of data sources, and bringing in the unification from the diverse and often siloed IT operational domains, including metrics, logs, events, alerts, and asset inventory sources. So having all of this data automated, it simplifies in establishing the asset dependency mapping by discovering the applications, your infrastructure, both virtual and bare metal environments, establishing the relationship between the assets as the events gets raised in real time, being ingested into the in our platform from multiple monitoring tools. It adds more context by overarching the discovered asset inventory and application dependency mapping data to get the more insights about how these events are related, which helps the platform to effectively correlate and reduce the alert noise and add more context, and converting the all of these correlated alerts and events into translating into actionable tickets. Okay, so with that, we'll talk about the RDAF architecture. So as we briefly talked about, the platform is built on top of cloud-native architecture. Either it can run in Kubernetes cluster environment, on-premise or cloud, or a plain vanilla Docker container environment. So it has three primary layers. One is the infrastructure application services, and then we have our core platform services, and then we have our application services on top of them. All of these services are microservices. They are deployed as containers. So when we talk about the RDA infrastructure, we have the messaging services, like which does the pub/sub, publish and subscribe kind of services for streaming the data, both internally and external to our platform. And then it has the S3 compliant object store service, which is Minivo. And we use OpenSearch. It is a schema-less NoSQL database for processing metrics, events, logs, and even asset inventory data as well. And we have recently introduced ArengoDB, which is a very popular graph database, which is primarily used for asset topology, for providing a very efficient full stack experience for both visualization and also leveraging that very simple to complex application to application, application to asset communication traversal, and leveraging that intelligence for the cross-domain correlation. And we use our Maria database, which is standard RDBMS, and which is primarily used for our platforms configuration, like RBAC access management configuration data. And we also use some of the alerts and processed incidents data into Maria database as well. So these are our core infrastructure services. They are highly available and highly scalable, which can be scaled some of the services either vertically or horizontally. On top of that, so we have our core platform services. We will talk more detail in the further slides. So we have the registry, and we have a scheduler. We have the collector for streaming management. We have the workers for distributed job execution for data automation. And we have other supporting platform services. And on top of the platform, we have application services. Our core application, one of the offering is our AIOps. And part of that application, so we have some of the key services like alert ingester, which takes care of all the incoming alerts through webhooks or emails, and the alert processor, which is the primary service, which does the correlation, and then we have the incident room service, and we have the ML and some other supporting application services for AIOps application. So while we have all of these services at the crux of the foundation layer of our platform, so we have another messaging bus, very lightweight and very efficient service is called NAS messaging service, which is our backbone messaging platform, which provides inter-process communication between all of our microservices within our platform. So while NAS is providing the IPC capability, we have some of the core infrastructure services, which are our OpenSearch, which is our NoSQL database, which captures all the data automation tasks, pipeline traces, and interact some of the core interactions between all of our microservices. And we have Minayo object storage service, which captures some of the RDAF Fabric platforms, artifacts, the configuration on the metadata files, which is shared across core platform services. And then we have the scheduler, that is one of the core platform service, which is responsible to manage all of our pipelines when they're being scheduled, when they're being run as a service, like continuously running pipelines, which are also referred as service pipelines, to process the real-time data. And then we have the one registry service, which maintains the registry of all of the microservices within our platform. So whenever a microservice bootstraps and initializes within our platform, they register with the registry service. It is a service which is responsible to provide the access to all of the rest of the services and information about, which service is available, which service is not available. And then we have the studio, which we will talk about in a minute, which is our DevOps, development instance, which interacts with our platform, which allows you to, build, test, and publish the validated pipelines into our platform. And we have the edge services like workers and event gateways, which are responsible to integrate with the end sources like your infrastructure, ITOM tools, and to collect the data either pull mechanism or through push mechanism. So these worker services which runs along with the platform, or they can run at the edge location. For example, if you have a central data center and then you have many branches, or if you are a service provider, if you have customer environments, which are of course, in their own on-premise or cloud, and if you have a very limited network access, restricted access, and where the on-premise or local infrastructure cannot be exposed over the WAN or through internet, in that cases, like you can deploy these edge services like worker or event gateway in the local environment at the remote edge locations or in your customer locations, which will integrate with the infrastructure locally and transmit the data securely back to the platform over SSL channel. Okay, let's talk about RDA Studio. So we take an approach of DevOps model when it comes to when we deploy our RDA Fabric platform in a typical production environment. As the data automation is at the core of the platform, so when we automate the data, either some of the capabilities are already validated, certified, and available out of the box as template, or if we need to build and develop or modify existing pipelines, we use the RDA Studio instance, which connects to our core RDA Fabric platform. Using the RDA Studio, which allows you to design the pipelines, test the pipelines, and you can validate the pipelines, and you can inspect the data. And once the outcome is established and the requirement is satisfied, these validated pipelines can be published to your production RDAF platform, and the platform will make it automated either through schedules or making it a real-time data processing service pipelines. Now let's talk about these individual services in a little more details. The first one is the RDAF, the core infrastructure services. So we have the NATS message bus. It is very lightweight in-memory message bus. It is primarily used for microservice processing, and also when we process the data either from the edge or within the platform, or streaming the data from the external sources, or even while using the data automation within the platform using the pipeline, exchanging the data between different pipelines or different sources. We use NATS as well. Along with the NATS, we also have Kafka, which is another messaging bus, very popular in the industry and well established technology. While NATS is a very lightweight, super fast messaging bus, the Kafka provides guaranteed message delivery to address the mission critical use cases. When you are processing the alerts and events in real time, and they need to be processed, and they need to be correlated, and they need to be ticketed, and make sure the end-to-end flow is foolproof and without losing any data for whatsoever. For that kind of use cases, we use the Kafka messaging within our platform. Not only that, if the platform allows to integrate exposing our Kafka messaging bus if the external tool needs to publish any mission critical alerts and events. Apart from these message bus services, we have some of the important different types of database services. One of them is OpenSearch. We widely use OpenSearch within our platform. It is a schema-less database, very user-friendly when it comes to data management, and it's a NoSQL database, and it is primarily used within our platform to store and process and visualize the data for analytics, such as like metrics, logs, events, alerts, and incidents. We also use OpenSearch for storing our asset inventory data as well. And then we have the Maria database. It is a RDBMS technology, and we use this for storing our platforms, user access management, some of the UI configuration, UI, our user interface, session management. And as part of our core AOS application, some of the critical data also being stored in Maria database, such as alerts, active alerts, correlated alerts, the incidents, and the incident being translated into tickets as well. And then we have the MinIO. It is a S3 compatible object storage service. It provides very rich API interface, a programmatic interface at a atomic operation level when it comes to file management, being distributed in a cloud-native application architecture such as RDAF. We use MinIO service to store all of our metadata files, our dashboard configuration, our dashboards, and the dependent pstream configuration. And when we use ML, all the trained models are stored within MinIO object store service. And we have HA proxy. We use this HA proxy as a load balancer front-ending our platform. So any traffic that comes into our platform, both through UI and as well as through anything over HTTP interface, it comes through HA proxy. And then we have the ArangoDB. This service we have introduced into our platform to address complex application dependency mapping, establishing the topology for the full stack visibility, and for simple to advanced and complex relationship traversals, we use the ArangoDB. It is a core GraphDB technology, which is purpose-built for addressing the topology relationships, traversals at scale. And then we have core platform services. We briefly talked about registry service. It is the primary microservice which maintains. That's why it's called as a registry of all of the microservices that have been bootstrapped and initialized within our platform. Any microservice within our RDAF platform to communicate, other platform and know about what are the other services that exist. RDA registry is the central in-memory database, which provides that information to rest of the microservices. And then we have the collector service. Collector service its primary responsibility is to provide the asynchronous asynchronous data processing for the streaming data. When the data is coming in a streaming fashion and writes to our streaming service, either through NAS or Kafka messaging bus. Collector service is the responsible service which subscribes to all of those subjects and the topics and streams the data and persists the data into our backend databases such as OpenSearch. Collector also provides the read queries, which is again goes through asynchronous and provides the the filtered results to the client. And then we have the API server, which is the primary service responsible for all the APIs, the interactions that happens among the microservices within our platform. It is also responsible to provide northbound, RESTful, Swagger-based, open API, standard-based APIs to third-party applications. And then we have scheduler service. It is one of the very critical service as part of our data automation pipelines. It is a service which is responsible to manage all the pipelines, either they are scheduled or either they are being service pipelines, and bringing all of these pipelines together as a service, which is referred as a service blueprints, which we'll talk about as we go through these slides. It manages all of the end-to-end pipeline lifecycle management by the scheduler service. And then we have other platform services. We have the workers. Workers are very stateless, and they can scale up and scale down. You can start with one worker and you can scale up like 2, 3, 4, 5, 6, and 10 or more. Depends on the amount of data you have within your environment, which need to be processed in real time or over the time. They can work as a group and provide an aggregated computing resource, which takes the pipeline execution on demand, or it runs the pipelines in a continuous fashion for the streaming data. And then we have the event gateway. Event gateway is another edge service which is primarily designed to stream the data from endpoints for syslogs. or security event logs from either Linux systems, operating systems, or Windows, or Unix, or virtualized environments, or the network devices like in switches, routers, firewalls, load balancers, and whatnot. And then we have the identity service. That is one of the core platform service, which is responsible for integrating with identity and access management, tools such as Active Directory, SSOs, either through SAML or OpenID standard protocols. And then we have the Access Manager. Access Manager responsible to apply all the role-based access controls and permissions. Resource Manager is responsible to manage all the RDAF artifact resources, within our platform, and also, it works along with the Access Manager to make sure the RBAC is appropriately applied. And then we have the User Preference Service, which is responsible to keep track of, to provide user-specific and user-centric personalization. As a user, when you log into the UI, and you can save some of your favorite settings, you can adjust the UI, you can modify the dashboard, or you can create some filters and you can save them as favorites. Those those settings are very user-centric. They are personalized. So all of this configuration is managed by User Preference Service. And then we have the App Controller Service, which is responsible to provide the framework for your dashboards, reporting, forms, etc., along with the report registry service. These two services will work together to provide the full and very rich, the visualization, analytics, reporting, and dashboards capability. And then we have the notification service, which is internal to our platform, which is being consumed by our different microservices for notifications, between the services. And then we have the portal service, which has two components. One is the backend portal, and the other one is the front end. The front end is an Nginx-based UI service, and the backend is our core UI framework. Both of these services will work together to provide our user experience and the web access, the UI portal, and that you see to access our RDAF platform. So now let's talk about our application services. Or one of the main application services is AOps. It is also referred as OIA, and its full form is Operations, Intelligence, and Analytics. It has some of the core application services for providing the core capabilities of AOps. Webhook is one of the HTTP-based front-end service, which provides the capability to integrate with ITOM or ITSM, or for that matter, any operations tool, which has support to send alerts and events over HTTP protocol. Is also referred as webhooks. And we have the alert processor, that is our core correlation engine service, which is responsible to provide the correlation engine policies, and in applying these policies and establishing the relationship between the alerts based on the applied policies, correlating the alerts, grouping the related alerts into an alert group, and translating them into an incident with the correlated alerts is done by alert processor. It's not only responsible to do the correlation, it is also responsible to apply the suppression policies as well. If you have a maintenance window, if there are alerts being generated, if they need to be suppressed, alert processor provides that policy suppression policy engine using which the system detects that these alerts are under maintenance and it suppresses automatically. It's not only that you can create the static suppression rules, either based on the severity, lower severity, or based on certain non-critical devices or endpoints being sending the alerts, even though you want to track them, but you don't want to ticket them, right? For those kind of scenarios, the alert processor is a core service which takes care of all of that capability. And then we have the IRM service, which is referred as incident room service, which provides the unified experience of bringing together not only the incident or the topology, the related metrics logs for providing the root cause inferencing. And we have the collaboration service, which is responsible to integrate with the any outbound ITSM tools, such as ServiceNow ticketing or remedy ticketing or PagerDuty or some other ITSM tools. And then we have the alert ingester, and this particular service is primarily responsible to normalize the incoming alert payloads. As the platform integrates with a different ITOM sources, when the system receives the alerts from, for example, VMware vRogs or Prometheus or Jabix or some other tool, the data comes in different formats. So the platform needs to normalize the data to translate all of these alerts, payloads and metadata into a common model, so that the model can be understood by the system and process the alerts and process the alerts into the correlation for the subsequent processing. So alert ingester is responsible for both inbound data transformation for the alerts, even outbound data transformation for ticketing. And then we have the event consumer. Event consumer provides some of the capabilities of endpoints, such as ticketing or integrating with the external message bus like RabbitMQ. Some of these integrations are managed through event consumer. Especially in the alerts to ticketing flow, that actual ticketing API integration happens and managed through event consumer service. And then we have the ingestion tracker service. As the alerts are being ingested, they are being processed, correlated, and being ticketed. So the end-to-end flow, the system tracks the different stages of the processing of these alerts, that transitions from alerts being mapped to transformed to correlated to incidented and the ticketed. All of these event states are captured by the ingestion tracker service. It is primarily used for visibility and troubleshooting and debugging if something doesn't work as intended. And then we have the configuration service. Part of this AOps application, we create different webhook endpoints, and we create the incident mappers, alert mappers for the alerts and events and the tickets, data normalization, correlation policies, collaboration settings, team settings. All of this configuration is managed by the configuration service. All of the above services which uses this configuration, and they interact with the configuration service and queries the necessary data for data processing. And we have other an application service called asset intelligence. Asset intelligence, core capability is to integrate with all of the assets and discover the data, your physical infrastructure like compute, network, storage, your virtual infrastructure, cloud native infrastructure, cloud infrastructure like AWS, Azure, GCP or other clouds, or any of your asset data, falls under this asset intelligence and analytics application capability. As part of the platform, all of the asset intelligence capability is included part of the RDA platform services itself. So it doesn't require any other application services like in AIOps service. Now let's talk about our edge services. So primarily we have three services. One is the worker. We briefly talked about worker. So these are stateless services, and they can scale up for the data automation processing, and they can be run in edge locations as well, especially in a restricted environment. When the pipelines are executed and the bots are executed for data collection or for the data transformation, those pipelines and the bots are executed, on top of the worker nodes. When the pipelines are executed through the scheduler automatically distributes the workload, across the available worker nodes. So the worker nodes can be grouped as sites, and they can be designated, by the site location. Let's say if you have a pipeline, which are meant to be executed, let's say in a Pune data center or a London data center or a Pleasanton data center in US, you can tag those workers through the site notation, which we'll talk about in the further slide. And the pipelines can be pinned down using the affinity rules to execute on the designated the site pipelines, site workers, to be able to collect the data which are local, from the infrastructure which are local to those workers. And then we have the event gateways, primarily used for streaming the logs data from your different infrastructure endpoints. And then we have the edge collector, and it's primarily built to integrate with the endpoints using the SNMP protocol. Any SNMP-based data collection, we use this edge collector service, and where we build the pipelines and execute. And edge collector service will connect to all of the SNMP-supported endpoints, such as network devices like switches, routers, firewalls, load balancers, and whatnot. It collects the data, and the data is transformed through workers, and the data will be processed and persisted into the platform for visualization and the application dependency mappings and analytics. Okay, so as the platform is highly scalable and built on cloud-native architecture, it is deployed in a distributed manner. It is highly available, and it has primarily 4 components when it comes to deployment. It has core infrastructure services. As you can see, the legend is green. And then it has the platform services. Legend is in light blue. And it has application services. Legend is light pink. And then you have the worker and agent services. They are distributed among in different virtual machines when you deploy it on a virtual infrastructure. And then when you deploy in a Kubernetes environment, the Kubernetes worker nodes running on a virtual machines. As it is being highly available, and when you talk about infrastructure services, there will be multiple nodes of infrastructure services will be run to distribute our backend database and messaging services. To make it highly available from the infrastructure services point of view, it requires a minimum 4 VM nodes. And for the platform platform services, it requires a minimum 2 or more. For application services, it requires 2 or more, and the workers, it requires 2 or more. As more VMs are provisioned, as these microservices from the application point of view, either let it be platform or our AIOps application or worker, they are stateless microservices. They can utilize these resources, and they can scale up horizontally and then distribute to address the demand for the data automation at scale. And on the right-hand side is you have the, your IT infrastructure. You have the identity management tools, and you have the IT operations and monitoring tools, and you have IT assets, ITSM tools like ticketing, and you have collaboration messaging tools, and you have the automation tools. All of these tools interact through our Fabric platform, either through RDA workers or even gateway on top of these secure ports like 4222 and 9443. So when you deploy in production from high availability point of view and disaster recovery point of view, how a typical deployment would look like. This would give you an idea about how our RDA Fabric platform can be deployed to make it highly available and resilient for both on-premise, local, HA point of view, and as well as site failover, disaster recovery scenario point of view. You have underlying infrastructure, compute, which is virtualized, and you would be having like 3 or 4 or 5 hypervisors. They are configured with no single point of failure with underlying bare metal servers, dual power supplies, dual network ports, multiple CPUs, memories distributed across multiple hypervisors, supported by a highly available switch infrastructure and highly available storage infrastructure. On top of that, you have the VMs, and if it is a K8s environment, you will have K8s infrastructure. And the application is deployed in distributed manner, and application provides the high availability at the application layer. For the disaster recovery and site-to-site failover perspective, the data need to be replicated using different industry standard replication technologies. So we have listed some of the popular replication technologies between the sites for DR purpose, but these are not limited to. Some of them are very popular: VMware vSphere replication, Nutanix replication, Zerto replication. All of these technologies, they replicate at the virtual machine layer. They keep track of at the virtual machine VMDK, block layer. So no matter what happens on application layer, these technologies will track all the changes that are happening at the raw block level. They keep track of all of those changes. They keep replicating to your DR site. They are very, very reliable and very established technologies in the industry, which we have tested and validated in our customer environments. Additional to these, VM to VM replication technologies, we also support the replication technologies at your storage layer as well. Some of these popular technologies are like NetApp SnapMirror, Dell EMC Mirror View. And if you have Cohesity, they have the replication technology at the storage layer. There's a backup technology tool called Veeam. They also support VM to VM replication. So when the disaster happens, leveraging these technologies, the application, the RDAF platform application can be brought up and make it live and serve the production in very less time. So when the platform is deployed and in a central location, and there is a requirement to distribute some of these workers at the edge locations, let it be the infrastructure restricted to be available over your WAN WAN network, or because of the bandwidth issues, or the customer environments like DMZ environments and different scenarios. In these scenarios, these edge services can be deployed closer to the edge location and the edge environment. And these workers, even gateways, the services which runs in remote location, they communicate to the platform securely over these ports. So only these ports need to be enabled between the platform and the workers and even gateways which runs at the edge location. So these ports are 4222 and 9443 and 9093. These workers, as it depicted in the picture, the platform will not have direct access to this end infrastructure. Platform will send the instructions to the worker, and the worker will have access to the endpoints. It uses the industry standard protocols, ports like like they are listed here: 422, 443, 80, 80, 80, 80, either TCP or UDP, whichever the programmatic interface is supported by the endpoints. Once the RDAF platform is deployed in production, okay, right? So how it can be, monitored and maintained, and make sure the platform is working in healthy state. When RDAF is deployed and integrates with many sources, being central unified operations tool is going to be very, very critical for in a customer environment to make sure the platform is up and running in a healthy state. So for that, the underlying host OS and container health metrics can be monitored. It can be monitored using any industry standard monitoring tools within an environment like any other application. So obviously, to get the complete insight about the platform, the underlying host OS, like either if it is deployed in Ubuntu or the Red Hat Linux operating system, the OS need to be monitored. And as the application is containerized and running on top of Kubernetes, the containers also need to be monitored. Some of the popular tools can be used, such as Zabbix, Prometheus, or Telegraph for that matter. And service logs. So RDAF application, as it runs in the production and as it processes a lot of data, critical data in real time, all of these microservices generate a lot of these logs. So these logs can be, can be captured for the visualization and the troubleshooting and the debugging purposes. So all of the microservices logs need to be captured. So part of our platform, we provide, built-in leveraging these open source technologies like FileBeat and Logstash. We have a monitoring service called log monitoring. When it is deployed along with the platform, these tiny services will make sure all of the application service logs are streamed and persisted into our platform feed stream, and through our dashboard, these logs can be monitored should there be any need to for debugging and troubleshooting. Also, it's supposed to forward these logs to external monitoring tools or external log management tools like an Elasticsearch, Splunk, or some other log management tools through syslog. So while these industry standard tools provide the infrastructure monitoring at the OS layer, at the container layer, and at the logs layer, the functional aspect of our microservices need to be monitored as well. For that, obviously, the monitoring service need to be aware of the internal nuances of our microservices, how they interact, how they function, how they operate. For that, we provide a standalone, containerized service called CFX Self Monitor. It is provided through our RDAF deployment CLI. Optionally, it can be deployed, and it can be integrated with RDAF platform. It periodically interacts with our RDAF platform and different microservices. It keeps polling and looks for the health metrics and health stats. It notifies the operations team should there be any issue. IT operations, data automation, addressing AOps use case. One of part of it is alert ingestion, alert correlation, noise reduction, ticketing automation. So that is one of the core use case. So around that, the platform provides a very, very flexible, very very wide range of use cases, providing the ability to integrate with any IT operations tools, and that is one. And other one is if you have an infrastructure where you do not have visibility of your infrastructure, where they are, what they are, what state they are, like from compliance point of view, auditing point of view, let it be aging infrastructure, both hardware and software, how they're related. So asset discovery and deep insights about the asset states and their application dependency mapping, how they are connected. For that use case, RDAF is very powerful that can be used. Other one is like if you have IT operations data, if you wanted to ingest and process them for analysis, applying either ML or statistical analysis for trending and baselining and anomaly detection, prediction, and forecasting, also RDAF can be used. Okay, so that's an answer for that. And then there was a question about MariaDB, whether we are using a master slave or a multi-master. So in our deployment and architecture, we use multi-master MariaDB cluster. We use the Galera clustering, and we use the multi-master. Okay, so hope that answers your question. So with that, let's continue into module 3, RDAF installation. Okay, so this slide talks about quick info about the runtime environment, the prerequisites to deploy our RDAF platform. Let it be either K8s environment or non-K8s environment. So when we talk about Kubernetes infrastructure environment, let it be bare metal or virtual infrastructure. So we support either it is a VMware, Hyper-V, KVM, Nutanix, AOS. From the OS point of view, we have certified and validated both Ubuntu and Red Hat Enterprise Linux. For a VMware virtualized environment, we have a standard OVF, which is pre-built, pre-validated, and integrated and installed with all the prerequisites like Docker containers, Docker Compose, Python versions and whatnot. In case of K8s, cluster version, we support 1.23.x or above. We have, we'll be able to deploy our application little lower version, but our recommended version is 1.23 or above. A Docker container environment, that is our foundational prerequisite between K8s and non-K8s. We need to have a Docker container environment, and the version can be 20.10.x or above. So in case of K8s, and especially when you're running the later versions of Kubernetes version, so from 1.24.x, the Kubernetes community, they have deprecated support for Docker runtime. The reason is the Kubernetes community, they need only the container runtime environment, doesn't need any API service which Docker typically provides. They want to make it very lightweight, so they completely remove the support. So for that, Docker community reacted and provided a supporting layer, a service called CRA Docker D. So this is the service which need to be deployed along with the latest version of Kubernetes environment. So Python, we need this especially for our CLI machine on which we deploy our RDAF CLI, the management CLI, using which we automate our application deployment, integrating with the K8s or non-K8s environment. For that, as of today, it requires 3.7.4 in a specific Python version. We are since Python 3.7.x version is recently deprecated. We are migrating to 3.12 in a month or 2 months time frame from now. For non-K8s environment, the underlying infrastructure similar to K8s, we have the virtual appliance, which is pre-built, pre-validated, which can be deployed on a VMware environment. If it is a non-VMware environment, other virtualization platforms like KVM, Hyper-V, or Nutanix, Acropolis, Hypervisor, we have the standard instructions where you can prepare either Ubuntu 20.x, 22 or 24.x, or RHEL operating system. You can deploy the plain vanilla OS and install all of these prerequisite runtime tools like Docker containers, Docker Compose, and configure the OS as per our application requirements. And you can templatize and you can use the template to deploy rest of the virtual machines in a distributed environment. Okay, since the RDAF platform is built as a microservices platform, cloud native architecture, obviously all of our application components are delivered as a container images. So as a provider of this platform, we provide all of these required container images through a secure cloud-based Docker registry repository service. It is deployed on our AWS account, secure, and it requires internet access to be able to download all of these microservices Docker container images. When we deploy in production environment, especially on-premise, it has an option to deploy a local Docker registry repository service, which can synchronize all of the container images from our centralized and cloud-based Docker registry repository service. Pretty much whenever we deploy production environments, we deploy this local Docker registry service on top of our management VM, so that these images can be pre-staged and make the upgrades much more predictable, just to avoid network timeouts and image not found issues while upgrading the production. So that these local Docker registry can be used to pre-stage and pre-plan if there is an upgrade. Not only that, if there is a restriction to provide access to the internet, we can use this management VM, restrict the internet access to only this management VM, and exclude the internet access to rest of the RDAF core platform virtual machines. So obviously, when we for our deployment, when we deploy this local Docker registry service, it needs to have the internet access either through restricted internet access through either proxy or white labeling the URLs which are documented. This particular service needs to have access to the our cloud-based Docker repository service to be able to download the images. So it is a mandatory requirement, and to be able to deploy and maintain, manage ongoing upgrades of our platform. This is a typical deployment architecture when it comes to managing our software images. On the right-hand side, it's a IT environment of a customer environment. On the left side, you have our cloud-based Docker registry repository service, which is running on AWS. So you have one small machine, which we typically use as a management VM. We use this to install our RDAF platform deployment CLI and other management tools, and along with configuring and installing the on-premise Docker registry repository service. In a restricted environment, it can be deployed in a DMZ, where the firewalls can be there, and restrict the internet access from the main platform instance. The internet access can be restricted through either HTTP proxy or through whitelisting the specific URLs, so that the outbound internet access is restricted and still the security requirements can be met. When we deploy our application on the VM instances which are designated to run our platform, they interact with only the local Docker registry service over port 5000. Even that access can make it unidirectional and outbound access over using a firewall restriction. If we talk about resource requirements, we have documented depends on the type of the environment. Well, if you wanted to try our platform for learning purposes and testing purposes, there is a single VM deployment which you can look at the resource requirements and you can deploy our application in a single VM. In fact, for this training exercises, the lab environment we have provided, we have created single VM instances for you to be able to try end-to-end functionalities and capabilities of our platform. In a small to medium POC or demo environment, you can deploy our application in distributed VMs in the span of 2 VMs or 3 VMs. But for production VM deployments, obviously it has to be distributed. And as we talked about the high availability requirements and scale requirement for our different application services, all of those prerequisites need to be met. So all of the the base requirements are captured in these documents. But obviously for production requirements, we request you to work with us so that we understand the environment, the use cases, and the data sizing, data ingestion, per day retention. And based on all of these data points, we recommend the required resources to be provisioned to be able to run our application production efficiently with reliability. So when we deploy our platform in production environments, we optionally recommend to deploy one of the core infrastructure service, which is OpenSearch, to deploy as a external OpenSearch cluster, especially when there is a need to stream the metrics data, syslog data, and traps data, and which need to be maintained for longer period, and also to apply the statistical analysis or ML analysis, ML techniques to analyze the data and visualize the data, presenting the data for baselining and trend analysis and anomaly detection and forecasting and capacity prediction and whatnot. So it can be deployed as a separate cluster and primarily addressing the time series database requirements. So OpenSearch is a open source technology, and we gave a reference link as well if you wanted to know about this technology and why it is so popular in time series database. You can refer that URL. So when we deploy, how do we deploy, right? So we provide a deployment management CLI called RDAF deployment CLI. The actual command line is referred as either RDAF or RDAF K. Depends on the type of the environment in which we are going to deploy. It is used for deploying, upgrading, and performing all the lifecycle management operations such as installation, upgrade, start, stop of the application. Along with, we also have a CLI called RDAC. It is a RDAF client CLI. Unlike RDAF deployment CLI, RDAC interacts with the RDAF Fabric and it provides all the management capabilities to interact and operate, with the RDAF. And it allows you to perform all the CRUD operations, dealing with and managing with persistent streams, data sets, dashboards, and providing some, health statistics, performing health checks against the microservices. So when we deploy in production, let it be KHS infrastructure or non-KHS on-premise, these are some of our common recommended guidelines to make sure these are applied against a production instance to make sure it is it runs optimally and reliably. When you're deploying on virtual infrastructure, the underlying hypervisor requires at least 4 minimum hypervisor hosts need to be needed to distribute our VMs. The reason for that is some of our infrastructure services like MinIO, OpenSearch, and Kafka, NATS, MariaDB, and ArongoDB, they need to be distributed minimum across 4 nodes. So let's say if there is a one of the hypervisor goes down, and to make your application is still available, serving the incoming mission critical data such as alerts and incidents and tickets, to avoid a single point of failure, minimum is 4 hypervisors. When it comes to data stores, since the data is distributed and for high availability, the data is replicated across all of these distributed application services. Try to distribute these shared data stores more than one, especially when these data stores coming from external storage arrays, distribute them across controllers so that the I/O is distributed equally to better I/O performance. When it comes to network, let it be application network or your storage network, make sure you have the network bandwidth is 10 gig or more. For application to application communication, within our platform, 10 Gbps is a mandatory. And when it comes to storage network, and the recommended protocols are, especially when it's virtualized over the 10 Gbps or more, you can use either ISCSI, FC, or NFS. When it comes to memory allocation, especially in a virtualization environment, so one of the beauty of virtualization is it allows you to overcommit the resources. But when it comes to RDAF Fabric platform, especially with the memory should not be overcommitted. If the memory, the allocated memory is, let's say 500 GB, the physical memory also should be available for the RDA Fabric platform to be able to run efficiently and optimally. When it comes to CPU overcommitment, it can be overcommitted, but the vCPU to physical CPU cores ratio it should not be more than 2:1 or max 3:1. Again, it is subjective to the type of the workload, the amount of data the platform need to be processed for addressing the AIOps use cases. So obviously, to distribute and make the application highly available, the infrastructure VMs, which are the most critical services which maintains and persists the data in the database layers, we need to make sure that those VMs are distributed and not single infrastructure service run on the same hypervisor host. At the same time, the platform and application services, when they are running in distributed, both workers and platforms and application VMs, they need to be distributed equally, among the available hypervisor hosts. When it comes to storage I/O profile, so obviously we use different database services and for different use cases. So our I/Os are very random and 50-50 ratio, and the throughput for the disk I/O at any point in time, it should not be less than 300 Mbps. At the peak, it should be able to reach to 700 Mbps. Depends on the workloads. So IO page sizes varies between 8K, 16K, and 32K because of the nature of the different database technologies we use. When it comes to IO latency, most of the time it can be 5 milliseconds, or sometimes it can reach to 10 or 20 milliseconds. But beyond that, it can severely impact the application performance. So when we deploy our application, right? So we have the metadata of the configuration, and using which our RDAF deployment CLI will be able to keep track of what is deployed, where they are deployed, what they are, and what version they are running, what state they are in, which machine the instance is running. All of that metadata configuration is captured in this folder structure. So OPT RDAF is the main parent folder, which keeps track of the configuration files of our RDAFabrix platform. And when we deploy the local Docker registry repository service, it uses the /opt RDAF-registry. So this is the folder under which it downloads and pre-stages all the Docker container images. It will also have the information about the cloud Docker repository credentials and the access points. And then we have the under OPT RDAF deployment dash scripts. This is the folder under which we keep the values.yaml, which will have the templatized version of all of the microservice configuration. Let's say if you wanted to increase the resource limits or resource allocation, this is the configuration file. We need to edit and to apply those settings, and so that RDAF CLI pushes those configurations when the application is deployed, across the distributed VMs. And then RDAF.cfg under OPT RDAF folder. So this is the one of the critical configuration file, which will have the information about how many RDAFabrix platform deployed among how many distributed VMs. What are those VM IP addresses, and which VMs are for deploying infrastructure services, and which VMs are for platform services, application services, and worker services. So these are the folder structure and configurations which are used by our RDAFabrix platform CLI to be able to manage both from lifecycle management point of view and as well as upgrade point of view. Now let's talk about the resource sizing. So obviously, when we deploy our Fabric platform, it comes with the default settings. When you deploy the default settings, the application will come up and it will function as usual. But obviously, when you ingest the data at scale, it will start suffering. It may not function properly with efficiency. So obviously, when you deploy in production environment, we need to size some of these resources, the allocated memory, and some of these configurations settings appropriately to address the business need. For non-KDS environment, under deployment scripts folder under /opt RDAF, we have the values.yaml file. This values.yaml file is common between non-KDS and KDS, but there are subtle different nuances. In non-KDS environment, all of the infrastructure services, platform, application workers, all of their resource settings are encapsulated in templatized in this values.yaml. This can be edited, and these values can be modified, and before RDAF can apply these settings against these deployed microservices. When it comes to KDS, For the RDAF, the platform application or worker services, values.yaml can be edited to define the number of replicas and what is the memory limit for each of these microservices, and you can push those changes. But when it comes to infrastructure services, we use the Helm charts. So each Helm chart is separate for each of these services. OpenSearch, Kafka, MariaDB, NAS, and whatnot. So each of these infrastructure service will have their own values.yaml. So if we need to update the resource sizing settings for these infrastructure services individually, the corresponding values.yaml need to be edited and updated. So within our infrastructure services, these two services has specific memory sizing settings, which are very important, especially running in production. When we talk about OpenSearch, it has a component called heap memory. It's a Java-based application, and heap memory is the critical resource which is responsible to keep track of all of the search queries, indexing, and the data processing within the database layer. By default, system comes with 4 GB as a memory heap. But when you deploy in production, and this need to be looked at, this need to be increased based on the requirement. The maximum support value for memory heap for this service is up to 32 GB. If the data size is more and the data the data processing need to be scaled up, we need to deploy more of these OpenSearch nodes. OpenSearch is as a service, as a technology, it scales really well horizontally, but it has a limitation if you wanted to scale vertically. So when it comes to MariaDB, so we have few settings that needs to be we need to look at when we deploy in production. One of the settings is bin logs. By default, the system comes with bin logs set to 3 days. These are to capture the data changes that are happening between the nodes and in case of recovery. So our recommendation is to set to reduce the value to 1, which is sufficient enough. And other MariaDB memory setting is DB buffer pool size. It comes with by default 2 GB, and it needs to be sized appropriately to make sure MariaDB can perform and offer the provides the query responses much efficiently. So all of these settings, both in MariaDB and OpenSearch, the buffer pool settings or heap setting is relative to your the service level memory limits. So these can be updated in values.yaml. In case of non-KTS, you can update values.yaml. If it is a KTS environment, you have the service-specific values.yaml, which you need to edit and update. And and using RDAF CLI, you can apply those changes. So these are some of the commands you can use to push these changes. So these changes are specific to the type of the service to which you would like to apply. If it is an infrastructure service, you can use in a non-KTS environment, you can use RDAF CLI. You can say RDAF infra upgrade. You can use the same tag version, and you can specify the particular service using the -- service parameter. So when you specify the same version, what it does is, it looks at the service version and it refers to memory setting and heap memory settings and whatnot, it detects the change and it applies against that microservice and it redeploys and brings it up. When it comes to platform and application service, it has the corresponding commands. RDAF platform applies the changes to platform application services. RDAF app command upgrade will apply the changes to AOps application service. Since the worker runs independently as a microservice interacting with the platform, it doesn't require any further arguments. You can use just RDAF worker upgrade the same version that it is currently running. When it comes to KTS environment, the CLI is little different. You need to use RDAF KTS. But as far as the syntax and the following parameters are concerned, it is same as non-KTS as well. So with that, let's talk about the RDAF artifacts. So within our platform and within the scope of data automation, so these are our primary artifacts that you interact while working with within RDA Fabric platform. We have RDA pipelines, and we have the persistent streams, and we have data sets. We have service blueprints and stacks for topology application dependency mapping. We have Alert State Manager, which we have introduced recently, and we have the dashboards for analytics. Now let's talk about RDA pipelines. So what is a pipeline in RDA? So in a definition, a pipeline is a collection of one or more data automation bots which are put together in sequence, executed in a sequence, to perform a data automation task. So when it comes to data automation task, you have a data ingestion, which means the data is coming into the platform, data is being processed and transformed, and data being searched and filtered, and data is transmitted to target. So how these pipelines are managed and administered? Within our platform UI, when you go to main menu under configuration, RDA administration, you have pipelines. You have both draft pipelines and published pipelines. Draft pipelines are used primarily during development phase. Once validated, tested, verified, they will be promoted to published pipelines. Published pipelines are meant for production consumption. As you can see, you can click on these pipelines when you are under this page, and it shows you the pipeline content. On the right-hand side, you have what are the actions you can perform on top of these pipelines. These pipelines can be edited, modified. These can be exported, and as they are being run, these can be visualized, viewing the traces to see the progress of the pipeline. Now, persistent streams. What is a data stream in a data automation world? Data streaming, by definition, is the process of transmitting a continuous flow of data, also known as streams, into or out of RDA Fabric. And what is a persistent stream? So persistent stream is an overlay on top of data stream. In case of data stream, the data comes in and get processed and transmitted to the destination. But if the data as the data is coming in, data needs to be persisted for analysis, debugging, or further analytics, right? So the persistent stream artifact will allows you to persist the data into the RDA Fabric platform. So by definition, it's a process of capturing the real-time incoming data stream and persisting into an index store automatically for data analysis, analytics, and reporting. When you talk about index store here, we are talking about OpenSearch backend service which persists the data. So when it comes to persistent stream, how the data flow works. So you have the different types of data being ingested into RDA Fabric platform. You have metrics data, you have alerts or events data, you have the logs data, traces, and asset inventory data. These data is being ingested into streams through either NAS or Kafka messaging bus. And these infrastructure services are integrated with RDA collector service, which is one of the core RDA platform service. It is responsible to subscribe to any of these streams which are configured for persistent streams. It registers and subscribes to these streams in real time as the data is coming in, data being processed. It collects the data and it persists it into the OpenSearch backend database. Once persisted, the data can be used for analytics and processing, for visualization, for metrics analysis, logs analysis, alerting, ticketing, and topology and whatnot. How do you manage these persistent streams? In RDAF UI portal, you can go to configuration, RDA administration. You have a persistent stream menu option. Under this persistent stream menu option, you can add new persistent streams. You can configure them. You can set the data retentions, and you can set the your index based on the data scale. And once it is configured, once the data is persisted, you can visualize the data. You can look at the metadata of the persistent streams, and you can look at the schema of the persistent stream as well. Now let's talk about a data set. Data set is widely used within our platform. By definition, data set is a collection of records which consists of columns and rows filled with data in a tabular form. Nothing but a CSV, a tabular data. Data set is also referred as a dictionary in RDAFabrix platform. Data sets are used for wide variety of purposes within our platform, which we'll talk about as we go through these training sessions. So how these data is being used? So when the data is being ingested in the form of CSVs, dictionaries like tabular data, and the data is being collected from asset inventory, this data is processed through RDA pipelines, either through streams or directly getting the data from the endpoints. When the data is processed, they are stored as the data sets in a tabular form, and the data is being persisted in Minayo object service. These data can be used for enrichment as a dictionaries. When we use as a dictionaries, they are commonly referred by the different RDA pipelines for the data enrichment. And if you're using for an ML analysis on the matrix data, all the trained models will be stored within these Minayo object service. And these data sets can be exported on demand as need basis as well. How these data sets can be managed within RDAFabrix platform? You can go to configuration menu, RDA administration, you have a option for data sets. Within this menu, you can add data sets by importing the data from a CSV file. Or you can add a data set, you can add rows manually with columns. These data sets can be visualized, and you can apply the filters if needed, and this data can be exported as CSV files. What is a service blueprint in RDAFabrix platform? Service blueprint is a collection of one or more RDA pipelines which are deployed together as a service. Let's say if you wanted to automate the data collection, data processing, data transformation, enrichment, and persisting, and for visualizing the data. If you wanted to define all of these RDA pipelines, build these pipelines, so you put together and to address the end-to-end data automation use case, service blueprint is one of the artifacts which will make it happen. Within the service blueprint, you have different types of pipelines which you can publish. Either you can configure the service pipeline as a service, or it can be configured as a schedule, or it can be configured as action. We'll talk about what these types are in a minute. What is a service pipeline? An RDA pipeline which is built to be executed in a continuous running mode, like a service, like a daemon. It is useful for processing real-time streaming data, such as logs, events, metrics, alerts. It is continuously a running pipeline looking for the data. As the data comes into the platform, it consumes the data and process as per the configuration within the RDA pipeline. What is a scheduled pipeline? RDA pipeline will be scheduled at a specified scheduled time. These pipelines won't be running all the time. These will be running only based on the schedule definition that you configured in the service blueprint. It is useful for collecting the data periodically, such as asset discovery and inventory. You can configure these scheduled pipelines as low as 2 minutes, 5 minutes. Or you can configure these pipelines running every hour or every day or week. What are the action pipelines? Action pipelines are on-demand execution pipelines. If you wanted to publish some of these pipelines to be executed by the user on demand, you can configure a pipeline as an action pipeline. When a pipeline is published as an action pipeline, it will be published as an action buttons. Okay, how do you manage the service blueprints within a RDAFabrix platform? You can go to Configuration, RDA Administration. There is an menu option called Service Blueprints. When you go there, it will allow you to create and define and configure service blueprints. Once it is configured, you can open the service blueprint, which will show the audit report of the service blueprint, which represents and validates and provides you whether the configured RDA pipelines are properly configured, there are no dependency errors, and it is in healthy state and ready to be consumed for production use. And within a service blueprint, when you click on the service map tab, what it shows is, it shows you the visual representation of how these RDA pipeline bots are built and how they interact, as part of the data automation. As you can see here, the bottom icon represents the pipeline. The pipeline has, two bots. One bot which is integrating with some AppDynamics APM tool, getting the data and processing through this pipeline and saving as a data set. And then when you click on the schedule, let's say if the pipeline is configured as a schedule, when you click on the schedule tab, it shows you the pipeline that is configured as a scheduled pipeline. Also, it will show you what is the version, at which worker site it is going to be executed, and what is the schedule. When it comes to schedule, it is a cron expression based schedule. So if you are aware of a cron, it exactly works in the same way. Okay, let's talk about what is the stack within our RDAFabrix platform. Stack is an artifact. It is an application dependency mapping, an artifact with a topological visualization feature within the platform. It is primarily designed to help and understand the relationship between your application layer and your infrastructure layer. And it spans across your virtualization, compute, network storage, your host OS, application services, and above. It provides the full stack visibility of running application within your heterogeneous environment. What is an alert state manager? It is a microservice which tracks health rule violations within the operations data, such as metrics and logs. It raises alert notification and sends them to internal AIOps application for further processing, for correlations operation and ITSM ticketing. This is a recently introduced service, and it is primarily being used for log management, log monitoring, and even in certain cases the metrics as well. Using this service, not only these metrics and logs, even the RDAF platforms, microservices, operational data which is being persisted within our P streams using the OpenSearch service. Even those data can be monitored and can be alerted, and the ticketing can be raised. And what is a dashboard? A dashboard is a feature in RDAF platform. It provides a way to visualize the data in the form of analytics and reporting using different views, which can be created for different personas such as executives, IT admins, and operators. Dashboards are very, very composable, very flexible, and very customizable to specifically fit user-specific needs within the IT operations landscape. How these dashboards can be managed and administered. So you can go to configuration menu and RD administration. You have a dashboard section. So within these sections, you will be able to look at the existing dashboards, or you can create the new dashboards. So dashboards are, the configurations are completely JSON driven, which we'll go through when we talk about dashboards and configuration. So within the dashboards feature, what is a dashboard group? Dashboard group is a way of grouping the one or more dashboards and assigning that object, the group dashboards to the end users. It is primarily used for presenting the IT operations view, such as alerts and incidents or asset inventory for the different domains and topology, selectively assigning based on specific user permissions. So dashboard groups can be managed through RD administration and dashboards, and you have a dashboard group section. This is where you can create different dashboard groups based on the different personas. Okay, so with that, I'll just take a brief pause. I think there was some questions. I think most of them are answered. There's one pending question. So it is coming back to the MariaDB. In case of any lag in either of the master, example, any lock occurs while querying and expire locks are insufficient, the table size is too large. So this is the question, and how do you manage? So obviously, we size the infrastructure first of all based on the infrastructure, environment, use case, data size, and everything. We have the purge settings, which purges the data, which manages the data within the tables. In case of when there is a data surge and if there is any underlying infrastructure issues, when there is a lag, the applications are designed such a way that it has all the resiliency checks and retries mechanism to be able to withstand any minor hiccups that happens between these MariaDB clusters. Okay, so in this module we are going to talk about our RBAC. So RDAF platform provides role-based access control through different user roles and provides support integrating with external identity and access management tools. By default, it comes with local user support for POCs and demos, and even for development purposes, you can use these local users. But for production deployments, it is highly recommended to integrate with your IAM tools, identity and access management tools such as Active Directory, single sign-on, we support SAML-based OpenID or OAuth. So users can be created, user groups can be created, users will be part of user groups, and user groups will be assigned with appropriate permissions and the roles. So when it comes to RBAC, this is the hierarchical architecture. So by default, when the platform is deployed, there is a default built-in organization. The artifact is called workspace. Workspace administration, which is called as an MSP. Within that, the platform allows you to create sub-organizations. Like depends on the deployment model, you can create one or more. Under these organizations, you have the corresponding user groups. User groups are attached to user roles, either as MSP admins or organization or tenant admins, or organization or tenant users or MSP users. MSP users will have the complete visibility of across the organizations. When it comes to organization users, either org level or tenant level admin or tenant user level users, they will have visibility into the corresponding organization resources as well, only. When the users are part of these user groups, whatever the roles associated to those user groups and the assigned permissions will be applicable for those users. So when it comes to user roles, so these are some of the out-of-the-box user roles that system provides, like MSP administrator, MSP users, MSP read-only, and organization level, the similar permissions. Along with that, we have a specific user role for API users as well. So these are the some of the default user roles that we have. We have MSP admin. MSP admin is a super admin, and as this user role, the user will be able to perform all of the administrative operations, like integrating with IAM tools, onboarding the users, building the pipelines, validating the pipelines, creating the service blueprints, dashboards, creating the correlation policies, and whatnot. MSP user will have the limited user permissions compared to administrator. MSP read-only user is primarily for read-only purposes at the MSP level. When we have the user role as the org level administrator, within the organization administration, the org admin will be able to perform the corresponding administrative operations. The org user will be able to consume only the dashboards and visualize the data. Read-only user is at the org level primarily for read-only operations, which means they will be able to only view the data. So we have the L1 user and L3 user, which with very limited privileges, and this can be used for IT operations landscape. So when we provide our dashboard access, right? So this is kind of a logical flow that represents how the process works. So the first thing is, obviously, as it is highlighted, the user groups need to be created. When you create the user group, it needs to be associated with the user profiles or roles, and those roles are allocated with the user permissions. Once those are assigned, users can be mapped to, like onboarded users, either local users or remote users coming from either SSO or Active Directory. They need to be mapped to these user groups. The user group and associated role will derive the applied permissions for those users. When the dashboards needs to be exposed to these users, first dashboard groups need to be created. Dashboard groups are mapped to to which user groups these dashboards needs to be allowed to be accessible and to visualize the data or to perform any operations. So what I will do is, as we publish the lab guide, I'll follow the same steps, and I'll walk you through those steps. But I request you to start the lab exercise in parallel. The first thing is I just wanted to walk you through the lab environment. Okay, so we have the Windows RDP jump host, and this is the public IP address, and it is you can connect using the same custom port. And we have unicasted the AD user credentials, and if you haven't received our, and then we have provided the lab environment details, like what is the working environment we have provided, different tool sets. For the deployment, obviously, the local Docker registry repository service, where we deploy it and how we are going to use it, part of our lab exercise. And then we are going to use the VMware VROPS tool. This is one of the monitoring tool which monitors the virtual infrastructure. And we also deployed for the lab exercise a JABX monitoring tool. And these are the IP address details which you will be able to access from that jump host. And these are the credentials. And then we have the VMware vCenter environment, on top of which we are running few virtual machines being monitored by both VROPS and JABX. And these details can be used to integrate to our RDAF platform for the lab exercises. So these are the IP address and user credentials. So these are the details for Windows host discovery. We have one machine for the lab exercise, and we have the Linux host, and we have the one Kubernetes cluster for the lab exercise, and these are the IP details and port and API token to integrate with it. And part of the lab exercise, we have few exercises. We can use email integration bots to send some test notifications. So these are the SMTP settings, and how to use it and how to configure them. We have captured all the instructions in the lab guide. Okay, so this is our lab environment guide, and we have segregated through day 1 and day 2, day 3, day 4. Hope you can access this document. And today we are going to do the day one lab exercise. It covers how to install our RDAF CLI, and how to set up and configure, install our RDAF platform, how to install RDF Studio, and how to create, how to onboard some of these, the default users like MSP admin, MSP user. So this is the jump host environment. So we have provided some tools which will be useful. Obviously, the PuTTY client. So this is the SSH CLI client using which you will be able to connect to your designated RDAF platform VM IP. And also you have the Notepad++, which we are going to use when we start working on the RDA pipelines. And then obviously browser to be able to access the RDAF platform and the studio once it is deployed. Okay. So I'm going to log in as the RDA user. If the VMs are deployed using our OVF, and the VM is deployed following our instructions to prepare the machine, So we have a default user called RDA user, and the default password is RDA user 1234. Obviously, once it is deployed, you are expected to change the password, but the default password is RDA user 1234. I mean, like you can use. I have a question. Like, do we need to use different PuTTY IP? It's not needed if it is the same instance, because it is going to be the same instance if you're sharing. So you can just use the PuTTY session, use the same IP to be able to connect to that RDAF VM. So the separate user is only to connect to the jump host. But once you connect to the jump host, you will have your own session, but you would be connecting to the same RDAF shared instance. Okay, hope that is that clarifies your questions. Okay, so I logged in to the machine. The first step is we need to download our CLI and install it. So I downloaded the CLI, and before we install the CLI, there is a one prerequisite because the CLI is a Python package. It is a prerequisite to have the latest, pip package to be installed. Sorry, not this command. Yeah, so pip install user upgrade the pip. So it is going to upgrade the pip package. Okay, so if it is already upgraded, obviously it doesn't need to upgrade. Then we are going to install the CLI. So once the CLI is installed, so what we need to do is we need to log out and log in once. Okay, I'm able to log in. So let me save these settings. Okay, run the RDAF command, RDAF version command to validate the installed version. Okay, so RDAF CLI is successfully installed, and the installed version is 1.3.2. The next step is to set up and install the Docker registry service. So the first step is we need to get the IP of the VM. So you can run the command hostname -i. So that will give you the the local VM IP address. So there is a command to execute to verify. Docker info. When you run the Docker info, you can see in the output there is one section called insecure registries. So this is where you can verify and make sure the on-prem Docker registry IPs are listed here. This is our lab environments one. This is going to be the instance IP which is allocated to you. So once this is done, we are going to install the Docker registry service. you apply the change, make sure there are no syntax errors. So once this is done, copy this one and execute this command. Okay, so it is successfully executed, and the configuration files are created. The directory structure is created. So you can look at here. I was presenting in the slides. So it creates the data structure, right? So OPT RDAF is one of the parent folder, and then for the Docker registry you have the RDAF dash registry. So once this is done, we can install the Docker registry service. For that, we are going to run this particular command. RDAF registry install dash tag 1.0.3. This is the version, which is the latest version that we support for installing the on-premise Docker registry repository service. So once this is deployed, you can verify that this container is running. Run the Docker PS. So in this case, we have only one service. So you can see the Docker registry service is deployed and up and running. You can check the logs to validate whether it is absolutely up and running or if it is having any errors. You can run the Docker logs -f and copy paste this Docker ID and enter. So it captures all the logs in the logs file, not inside the container. So I think it is in good shape. Now run the command RDAF registry list dash tags. This should show the list of the application services and what are the available tags. If you're deploying for the first time, I had deployed this service before. That's why it is showing some of the older data. But in your case, since you're deploying for the first time, the tags will show empty. So which is expected, and that means the registry service is installed appropriately. So since in my case I have these images, what I can do is I can delete these images and re-download them. So for that, what I'm going to do is I'm going to run this RDAF registry. I mean, this step is not applicable in your case. Delete images, tag, I can say 103. I'm just giving all of these tags as a comma separated values. So when you run this command, and this command is useful, obviously, when you start downloading these images, and when we release the newer version, and you keep downloading these images. At some point, obviously, the /opt directory under which it stores these downloaded images will be running out of space. So so you should be monitoring this mount point and periodically, not that frequent, but whenever there is a need to upgrade a newer version, just check the already existing images. If it is touching like 70% or 80%, you can run this command to delete the images. Once these are deleted, you can run the list tags. Okay, you can see that there are no tags are showing up here. Okay. Now we're going to go back to the lab guide. Okay, now we are going to reconfigure the registry service to point to the lab repository service. Okay, I'm going to update this and update this RDAF VM IP. So make sure there are no syntax errors here. Copy this. So what we are seeing in this command is this local VM. This is going to be the VM for running the Docker repository service. And for this to synchronize the Docker images, and this is the source host. So in a typical production environment, it is going to be the cloud instance, which we run previously. Since this is a lab environment, we don't want to download from the cloud. So we wanted to download from our local lab Docker repository service itself. So we are pointing it to, this is the source repository service from which it can download and synchronize the images. So now the step is configured. Now I'm going to run the fetch tags. So as given the command in the lab guide, we are downloading the infrastructure service tags, which is 103 and 1033, and our platform version, the latest version 3.7.1 as of today, and 7.7.1 for our application service. So it is going to take in a couple of minutes. Okay, so so all of the Docker images downloads are completed. Once these are downloaded, you can run this command just to view RDAF registry list -tags. Pretty much majority of these services are populated with corresponding tag version. So there are some of them, so I have captured in the documentation. These services can be ignored where you are seeing the empty value. Okay, so once the Docker images are ready, we can set up the RDAF platform. So for that, we need to execute RDAF space setup command. And it asks for EULA agreement. You just need to say yes. And SSH password of RDAF platform. So obviously, since we are deploying in single VM, there is going to be the password of that VM. But when you deploy in distributed VMs, you need to make sure the password is consistent across all of the VMs on top of which you're going to deploy the RDAF application services. So that they are infrastructure or platform or worker or application services. In all of these distributed VMs that are going to be managed and deployed through RDAF CLI, so SSH password has to be same across all of the VMs. So I'm going to enter the password. Okay. Subject alternate for certificates. So during this setup, it is going to take all the user inputs, ask me about where can I deploy the application services, where can I deploy all the infra services like MariaDB, OpenSearch, NATS, Kafka, and worker services. So part of this, it generates based on the IP address list that we give, it generates the self-signed certificates. So in some scenarios, additional to these IPs, the public-facing IPs could be different, or there could be some custom DNS name. In such cases, basically this input is allowing you an opportunity to provide additional IP addresses that are not captured part of the RDAF setup. So in this case, we don't need, so it's an optional in this lab exercise. So we're going to set, we're going to hit the enter. Now it is asking for the platform service host IPs. So it is going to be the IP of this machine, 1098. So this is going to be your VM, the allocated VM IP. So this is my instance, so that's why I'm entering my instance IP address. It is asking like, is the deployment is going to be HA mode? No, because it's going to be a single VM deployment. Answer no. And then the application service host. So I'm going to give the same IP address because we are going to deploy all of the services on the same host. And then what is the admin organization? So this is the workspace MSP organization. So the default is CloudFabrix, but either you can leave it default or you can give any name. So in this case, I'm going to hit enter, keeping it default value. Docker registry CA set path. This is optional since we already set up the Docker registry. It doesn't require any certificate path in this case. Otherwise, if there is a need to specify this path, the certificates are available under /OPT/RDAF/search path. That is for RDAF platform. In case of in this case, it is specifically asking for Docker registry CA cert path. So it will be under /OPT/RDAF-registry/cert path. So that is the location of the Docker registry settings, the certificates. So in this case, we don't need to specify since we already configured. So I'm going to hit the enter. On the worker host IP, I'm going to give the same IP. Event gateway, it is going to be the same IP as well. And then it is asking the infrastructure host. It already picked the default IP address of this VM. So so we don't need to specify because we are going to use the same VM IP. And the Minayo server, same IP. The username, this is the default username. If you want, you can change. The usernames and passwords are auto-generated. So the password is auto-generated. If you want to change, you can change at this time, but I'm going to take the defaults. IP for the MariaDB, same IP. Username and password, the defaults ones, the auto-generated ones. And it is asking for OpenSearch server IP address. Same IP, taking the default credentials. Kafka, same IP. Kafka doesn't require credentials. It's a purely certificate-based authentication. GraphDB, same IP address, default credentials. HA proxy, okay, and then I hit the enter. So now what it is going to do is it is going to create all the necessary folder structure, generates the self-signed certificates, and it runs all the prerequisite configuration for NAS, OpenSearch, MariaDB, other services, based on the requirement. So it is creating a prerequisite container for OpenSearch to generate an access key, and that is going to be used as part of the service installation. Okay, as you can see, it is able to complete the RDAF setup, and you can see the message setup completed successfully without any errors. So hope you're able to follow the steps and able to complete the setup. Okay, so if you have any questions, you can post your questions. We are happy to answer. Or if you are having any issues accessing the lab environment, please feel free to post those questions as well. Okay, so as the setup is completed, the next step is to install the infrastructure services. So for that, we are going to run the RDAF infra install command. I'm going to copy paste the command from the lab document. So it is downloading the images of HA proxy and NAS, Kafka, OpenSearch, GraphDB, MariaDB, Minayo, all of these services from the Docker, the local Docker registry service that we deployed and pre-staged all the images. It completed installing all of the infrastructure services, and it is showing the final output, right? Let's give a couple of seconds, and then we can quickly run one infra health check command to validate if all the services are up and running. Before that, there is a command to upgrade the HA proxy service. So the HA proxy service has a newer version, 103.3. So what we are going to do is, while other services are getting initialized and running, we are going to run the command to upgrade the HA proxy service. So we have a command RDAF infra upgrade, and with a newer tag version, and specifically we are going to specify the service for HA proxy to upgrade. So this is the command RDAF infra upgrade. Give the newer version of the tag and specify the service. So if you don't specify this argument, it thinks that it is applicable for all of the services and it tries to upgrade. Okay, so it is downloading the upgraded version for the HA proxy, and it is going to redeploy the HA proxy service. Okay, it is completed, and you can see here HA proxy is redeployed, and you can see the uptime is less than a second, so which means it's just up and running, and the tag is updated as well. We are going to run the RDAF infra status command one more time. Okay, it is showing all of the running services, and then we are going to run one health check command for the infra services. RDAF infra health check. So what this command is going to do is it is going to connect all of these infra services and verifies whether the firewall port is open, the status is up and running, the port is accessible, all the basic checks. So before we can continue deploying the RDAF platform, application, and worker services. And as you can see, so it is able to communicate to all of the infrastructure services on the corresponding checks. Okay, now the infra services are good. Now we are going to deploy the platform services. So for that, I'm going to use the RDAF platform command, the install argument with the tag 371. So this is the command, and it is going to pull all the necessary RDAFabrix platform related images, and it is going to install them. It may take a couple of minutes. Let's give it a wait and continue once it is completed. Okay, looks like there is one question. What is the difference between GraphDB operator and GraphDB server? So GraphDB operator is a supporting service using which the GraphDB server and deployment of service is managed. So it's like a supporting service than a DB server itself. So the server is the primary service which serves the DB, the GraphDB functionality to the application. So we have this operator even in Kubernetes as well, Kubernetes deployment. So the operator has the built-in automation capability to understand how to deploy the necessary components and how to manage the boot up sequence, cluster initialization. All the intelligence is built into the operator. Okay, so hope that answers your question. Okay, so we are able to successfully install the RDA platform services. As you can see, one log message, it is able to initialize, and you have a message UI can be accessed at this URL through a browser. And there is a default user, admin@cfx.com, and the default password is admin1234 that we captured in the lab document. And you can see all the installed services here, right? All the microservices which are part of our core platform, and they are running on which host, IP address, uptime, what is the container ID, and what is the version. Okay. So with this, we are going to move to the next step. The next step is installing the RDAC CLI, the RDAFabrix client CLI, which interacts with the RDAFabrix application. The command is RDAF RDAC_CLI install the tag version 3.7.1. Once it is the command is executed, the command we need to run is RDAC pod, which basically initializes the Docker image and start downloading the image and installs the CLI. Okay, enter the RDAC pods. So it is initializing and downloading the CLI image. Okay, so the command is executed and then it returns the health stat of each microservice. So you can read this output, right? So there is a user preference microservice. What this is saying is it has these 5 dependencies. The service status itself, the MinIO S3 service access, the connectivity is good. And it has a dependency with the registry service. It says my dependency is absolutely fine. It is saying as okay. And the service initializes status, which is good. And it needs the DB access. Even the DB access is good. So similarly, every microservice reports its dependencies and their health status. So you can scroll up through all of these microservices and make sure every service is showing as their health status and dependencies health status as okay. Okay, so all are looking good, and platform services are deployed, RDAC CLI is deployed. We are able to use the RDAC CLI to interact with the RDAFabrix services to get the health statistics and their running status. Okay, with that, let's move to the next step. So when we deploy the RDA platform, there are like 2 modes you can deploy. One is absolutely in platform mode, which means your use case is purely data automation, and you don't have the requirement of doing the event correlation and suppression and ticketing automation, those kind of use case where they are primarily the AIOps related. So for that, if you deploy the just platform versus if you want to install the AIOps application, there is one application command we need to run, which is documented, and that's what I'm going to run here. So RDAC, RDA app configuration, and type we are setting as AIOps, which means we are deploying the RDAF platform in AIOps mode, which means like it installs not only the platform, it allows to install the AIOps application. Okay, once we run this command, we have to stop the platform services and restart it. Okay, for that we have a command called RDAF platform stop and the platform start. So I'm going to run the platform stop. It is going to stop all the platform services. I'm going to say yes. Now it is stopping all of the platform application services. Okay, all of the services are stopped, so I'm going to start the services. RDAF platform start. Okay, all of the services are brought up. So they are going to be started, initialized. Let's give a few seconds. We can run RDAF platform status command to check all the container status and their uptime. So most of these commands, pretty much 95% of the commands are same between Kubernetes and non-Kubernetes. In Kubernetes, one difference is there is no concept of stopping and starting a service. So in non-Kubernetes, when you say RDAF platform stop, what it does is it just stops the container service instead of redeploying the container. But in Kubernetes, so since there is no option, you have a down and up command. what it does is it basically makes downgrades the replica count to 0, which removes the pod, and then when you do the up, it redeploys the pod based on the number of replicas. So that is the one difference between K8s and non-K8s as far as starting and stopping sequence of these platform infra application services. Okay, now let's run the RDAC pods to make sure we see all of these platform services. Okay, so they're all up and running, and there is a caveat I mentioned in the lab guide: the scheduler service should be in the later state. So it is also in the later state, which means the platform services are good. Okay, with that, we're going to move to the next step, installing the worker. I'm going to run the RDAF worker install with the tag version. Okay, it is downloading the worker image, and it is going to deploy the worker service as soon as it completes creating the container from the image. Okay, so it is able to complete the installation of RDA worker. Let's run the RDAF worker status command. It shows the worker service container status. So it is up and running for 90 seconds, and this is the container ID. And then we can run the RDAC pods command so that we can see whether worker is completely initialized and registered itself into the RDAFabrix. Okay, so you can see the worker here, and it is up and running. It is initialized and registered into the RDAFabrix, and this is the site. So this is what I was explaining. You have concept of this site group. So if I install multiple workers with the same site group, when you submit the pipelines pointing to the site, so the pipelines will be executed in a distributed manner. And if you have service pipelines, multiple instances of service pipelines, they will be distributed on the multiple workers as well. And so if you have the remote and edge service workers, so you need to make sure that this site is configured differently. But if you use the same group name, then definitely it would cause issues because the worker is running in different environments, and the kind of access it has local to that environment may not be applicable to the pipeline you intended to run. So that's why this site setting is important. So this is defined through environment variable as part of the worker Docker Compose configuration. So it is documented. It is available in our public documentation. You can refer how to change this site setting. So worker is deployed, and now we can move to the next step. Now we are going to deploy the event gateway. For that, I'm going to run RDAF event_gateway install command with the 3.7.1 tag version. Okay, so event gateway is deployed. Let's run this command: RDA event_gateway status. Okay, it is up and running. To check its registration into the RDAFabrix, its functionality is slightly different than worker. Unlike worker, which is primarily for running the pipelines, event gateway doesn't execute any pipelines, but it acts as a data receiver for real-time streaming data such as logs and events and alerts. It depends on the configuration. So it registers itself as an agent. So in order to see the event gateway part of the RDAFabrix, we need to run the command called RDAC space agents. Okay. So you can see that this RDA event gateway is registered, and so event gateway has a concept called site, and this is the default site name. Okay, so with that, we are able to complete the worker and agent, and this concludes the installation of platform services. Now we are going to move ahead and install the AOps application services. So for that, I'm going to run the command to deploy the application using the RDAF app command. Okay, so it is successfully installed the AOps application services. Going to run the RDAF app status command to view the status of these services. Let's give a minute or two to let these services get initialized and settle down. And we can run the RDAC pods to make sure these services register themselves into the RDAF RDA Fabric registry. Okay, you can run the command again. Time. Okay, that confirms that all the services are keep up and running. There are no restarts, so that is good. And now I'm going to run the RDAC pods. Let me. Okay. Yeah, we can see the app services are registered. You can see the IRM service, collaboration, processor, ingester, configuration service, event consumer, ingestion tracker, ML config, SMTP server. So app services are looking good. So we are going to run RDAC health check. So it is going to query all of the app services as well, and request to report their health status and their dependency checks. We can scroll up and to make sure everything is showing as okay. Yeah, all looking good. So app services are good. Okay, so yeah, we are able to deploy all three services, three categories of services: infra, platform, app, worker, event gateway as well. Now we are going to deploy the RDF Studio, the DevOps instance, which we are going to use to develop, test, and validate the pipelines, part of this course. And we have some lab exercises. So for that, we have to deploy the RDF Studio instance. It's a one container service which will be deployed, and it integrates with the RDA Fabric application services. Okay, so there is a section install RDF Studio. I'm going to follow those steps. Okay, so we're going to follow the RDF Studio installation steps. The first step is we need to create the directory structure, which we captured in the lab guide. So I'm going to run those commands. Just copy paste all of those commands together. So it created RDA_studio under OPT and some subfolder structure here, and then change the permissions to set to RDA user, the currently logged in user, to the RDA_studio, and change the directory location to OPT RDA studio. And with that, we are going to create a Docker Compose YAML file. Okay, so I'm able to create the file. Before we deploy the service, obviously we have to edit the image location, the Docker registry IP. So here, as it highlighted in the document, we have to update with the RDAF VM instance on which we deployed the Docker registry service. So if it is your instance, this is going to be your VM's IP address. So for that, I'm going to use a VA editor, RDA Studio, and go to that image line and update the IP address here. Okay, so please make sure and pay attention, there are no typos here, just to avoid any syntax errors. Few settings here. So the mem limit defines the maximum amount of memory the studio can use. So if you're using RDA Studio, especially when you're sharing and running multiple pipelines, so you need to be wary of this memory because as it provides the inline data inspection capability, it maintains a lot of transformed and processed data in memory. So if you're running and working on large data set, it can potentially run out of memory, right? So this is a setting if you wanted to update. These are the volumes, the host mount points it mounts for the configuration. And the ports configuration, this is the port 998. If you wanted to run on 443, you can configure the 443 and you can disable the 998 as well. So it supports both. And then the important one is RDA network config. So this is the configuration file which we are going to copy from the RDAF platform. I'll walk you through the contents of this config.json as well. And these are the default credentials. So by default it comes part of the configuration, but if you wanted to update this password, you can definitely update and redeploy the Docker using the Docker Compose. It will change the credentials, but we are going to use these default credentials for the lab exercise. Okay, so I updated the IP and I saved it, and then I'm going to copy the RDAFabrix network config JSON. Okay, I ran the command, but let's before we go to the next step, let's quickly edit this file and just look at the contents. So this config file will have the information about how to access the RDA platform by the edge services. Let it be RDA worker, RDA event gateway, studio, or even edge collector. Any edge service that communicates and works with the RDA Fabric platform, Fabric. So it uses this network configuration, which will have the information about the NAT's endpoint details and the port, and it will have the certificate and the credentials in the encrypted. This is the encrypted password basically, and then you have the Minivo host, its endpoint details and its credentials are encrypted. Similarly, it has information about MariaDB and your Kafka, and also it has information about your OpenSearch. ES means Elasticsearch, nothing but OpenSearch in our platform, and then the GraphDB endpoint details also. It will have the IP address, port information, and credentials in the encrypted format. So that step is completed, and then we are going to run the Docker Compose command to bring up the RDA Studio service. Okay, so it is able to bring up the Docker Compose, RDA Studio container service, and it is up and running. Let's look for that service. Docker PS grep for CFXDX. It's an image name for the studio. It is up and running, and then we can look into the logs of the studio container. So when we deploy the RDA Studio, so the application is built on top of a Jupyter notebook. If you're a Python programmer, familiar with Jupyter, obviously you'll be able to understand about this Jupyter application, web application. So our Studio application is built on top of that. So when we bring up the RDA Studio for the first time, it takes a few minutes to initialize itself and configure the Jupyter web application. So we just monitor for the logs, and once it completes, it will show the URL with the port number and HTTP URL with the port number. That means the application is completely initialized, and it is up and running, and it is ready to be used. Okay. So now you can see these messages, which means the application is fully up and running, and it is good to be accessed now. Okay. Okay, and that is done. Now we can check. We can open up a browser and try to access the studio. The VM instance IP address 9998 and enter. Okay, so it is going to ask the username and password. You enter those details. RDA demo. Okay, so you can access the Studio application here. Okay, so with that, this exercise is done. As far as Studio installation is concerned and accessing it, the web interface. With that, before going to the RDAF portal, we have few steps to perform as part of the lab exercise. So we are going to move ahead, ahead with those steps. So during the presentation, I talked about once these services are deployed, and especially for production, even for demos or POC, it depends on the size of the environments and the data automation use cases you plan to do. So the resource settings, especially memory of certain services, need to be adjusted accordingly. So we're going to perform those steps before we start looking at the RDAF platform UI portal. So now going back to the CLI. So now what we are going to do is we are going to update the memory settings for OpenSearch service and its heap memory, and as well as the worker service. This is just to show you how these configuration files can be updated and how the resource settings can be applied and deployed against those services. So we can go to CD OPT RDAF deployment scripts, and then you have values.yaml. So when you go to the beginning of the file, you can see the configuration information for all of the microservices here, both intra, platform, worker, and application services. Here we are interested in OpenSearch. There is a heap memory setting. This is one of the important setting. By default, it comes with 4 GB, which is sufficient for a small deployment like this. But so if it is a little medium to production environment, this needs to be adjusted. So what we are going to do is we are going to change it to 5 GB. Okay, and we are also going to change the mem limit to 10 GB. So when you increase the mem limit, these mem underscore limit and mem swap underscore limit both need to match. This type of setting is not applicable in Kubernetes. It has only single parameter, but in case of non-Kubernetes, you need to make sure these both of these values match. You have the mem reservation. So mem reservation means when the container service starts, it reserves that memory, whether it uses or not. Okay, so let me repeat these things. I was trying to explain these settings. Yeah, so the mem underscore limit and mem swap underscore limit, these two settings need to match in case of whenever we are updating these settings in a non-Kubernetes environment. In case of Kubernetes, there is going to be only one parameter to update the memory, so that which is these two parameters consistency is not applicable in Kubernetes. Memory reservation, so whatever the values specify, it reserves that memory for the service upfront when the service gets started, and to make sure that it has enough resources to come up and initialize itself. So the limits are upper limits. That doesn't mean that the service will take that specified memory upfront when it comes up. Let's say if it is consuming 6 GB and if it's not utilizing 4 GB out of the limit, that memory is available for other service, other microservice if needed. So upper limit is basically set of boundary just to distribute the resources appropriately, just to avoid running out of memory. Okay, it is done. Let's run the RDAF worker status. You can see the worker is up and running. This is the container ID. How do we make sure these settings are applied? We can run Docker stats and the container ID. When you run this command, it shows the current utilization of this container, and part of that it has this memory usage. You can see this. This is the current utilization. The limit has been increased from 8 GB to 9 GB. Right. So this is how you can validate and make sure the updated resource settings applied in values.yaml are properly applied after upgrading the command. I mean running the upgrade command for that service. Since the OpenSearch is restarted, let's run the RDAF infra health check to make sure everything is looking good. Okay, so OpenSearch service is up and running. It's port connection, service status, firewall port, all looking good. Then we can run the RDAC path, RDAC health check. Okay, you can verify the status here. It's all looking good. Okay, so the changes are applied, the services are restarted, and they have been validated. It's all looking good. With that, we can go to the RDAF UI portal. So to access the UI portal, it's HTTPS. It runs on port 443. Login, the updated password. Okay, so we are able to log in here. So this is the landing page, and this is the home page, and this is the main menu. And you have these main menus here. You have the user dashboards. When we configure the dashboards and when we publish the dashboards, those will show up here. And we have a configuration. Within configuration, we have the RDA administration, under which we'll be able to perform all the pipeline management, dataset management, P-stream management, stack management, service blueprint management, GraphDB topology management. All of the RDA artifact management, will be done under RDA administration. And then we have RDA integration. So this is where we add all the source integration credentials, like username and passwords, target IP address. All the credentials, will be managed under RDA integrations. And then we have app administration. So this is where we configure and manage and apply and administer AIOps related configuration information, like alert mappers, normalizing the data from different alert sources, integrating the service node ticketing, and creating the incident mappers, creating the correlation policies, suppression policies, and all of that will be under apps administration. Fabric Health will show the RDAFabric platforms, the health status, and also RDA pipelines, so job status, execution status, and the statistics of how the RDAFabric platform itself is running, from overall health point of view. And then we have the administration at the platform level. This is where, it allows you to configure the onboarding the users, user groups, integrating with the ADs, SSOs, icon management, and white labeling. All of those operations are performed under administration. So as a starting step, we are going to go under administration, and we are going to create one organization as a first step. So since we logged in as an admin user, so this is the default super admin user. It's also called as a workspace admin. So we are going to create the organization first to onboard a tenant. So go to organizations here and click on add, and then create acme org. Follow the document. And customer tag. So the tagging is allows you to tag with a particular string, and which is used during the application permissions, roles, and all of this. We'll discuss about when the topic comes. So just give the same name. Click on save. So it created the organization, and now we are going to go to the user section and create the user groups. Click on the user groups here to create a user group. We deployed RDA Studio. We would like to verify and make sure that the studio is properly configured and able to interact with the RDAFabric platform. So part of the configuration, we copied the config.json, which has all the RDAFabric endpoint settings, using which the studio should be able to communicate and integrate, right? So how can we verify that, right? So in order to open the studio application, there are two ways you can do. One is you can just click on this CFXDX Python 3 to open the Jupyter notebook, or you can click on File and New and Notebooks. So these are two options. I'm going to go ahead with this one. When you open this Jupyter, it takes a little while, in the sense like a minute or two to initialize, sometimes pretty quick. The status is captured in the bottom. So it is showing as connecting. So you have to wait until it shows idle. Okay, idle means the notebook is ready. And now you can enter the command studio, like a function, like open and close the parenthesis. You can, if you're using Mac, you can hit Option Enter. If you're using Windows, you can use the Shift and Enter. Either you do that or there's a play button here, right? You can do that as well, right? So that opens up the RDA Studio application. And from here, there is a drop down, the menu option. And here we are trying to verify and validate if the RDA Studio is able to talk to RDAFabrix platform or not, right? So click on this cluster access. When you click on the cluster access, if you're able to see all the pods and microservices from the platform, that means RDA Studio is set up properly and it has no network issues or credential issues or port issues in talking to the Fabric platform. And whatever we see in the RDAC pods command output, we will be seeing the same output here, which shows all of the running and registered microservices. Okay, so this pretty much concludes the lab exercises for today. I'm open up for any questions should you have. Hope you guys are able to deploy the studio and the platform, able to access the UI, and able to validate all of this configuration. Log out and log me back in as MSP admin. Okay, I'm able to log in. So this pretty much concludes the lab exercise. But today, we made good progress in the sense like we were able to set up the on-premise Docker registry, and we were able to download the image tags for infra services, platform services, application services, workers, and everything. And then we were able to set up the platform. We were able to install all of the infra application and RDAC CLI, and we were able to run some maintenance commands like getting the status and updating the resource settings and restarting the services. And we were able to install the RDA Studio and able to connect to the Fabric. Group name, description, and then scroll down and select the role. So this is where we associate the user role to the group. Okay, so we are going to select the MSP administrator here. And then as an MSP admin, which organizations you wanted to allow the access. Obviously, being an MSP admin in this scenario, we wanted to give full access to these organizations. So when you have multiple organizations, you have an option to select either all of them or selective or sub-organizations. Click on Add to add the user group. Okay, so user group is added. And then we are going to create another user group called MSP_users. Create, click on Add Group, MSP users. Come down, select the role, MSP user role. And from the report, select the organization. And click on Add button to add the MSP users group. Okay, so now the step is done. Now we are going to create users. I'm going to create MSP admin. Okay, I'm going to use Acme admin following the lab guide instructions. And the username is Acme admin @acme.com. So what we are doing is we are creating the local user here, right? So when we integrate with the external identity and access management tools, such as Active Directory and single sign-on, SAML, OpenID, or OAuth, we can select this remote user option, right? When you click on the remote user option, It lets you to onboard the users from the external tools and map them to the corresponding user groups here. Okay, you're going to create this local user, click on submit, and this user is created. We are going to create another user, Acme user, add user, add group, and I'm going to create a MSP admin group.